Welcome to Pratidhwani, where we try to humanize science. It is my absolute delight, pleasure, and an honor to introduce you to my guest, Professor Gautam Menon. Gautam is somebody who actually really adds, both beauty and knowledge to the discourse what we generally have in terms of science or even beyond science. There's also an element of aesthetics and also an element of intuition which comes into the discussion what Gautam brings in. Gautam also has a very fascinating trajectory, starting as a physicist and who actually has really contributed very deeply to biophysics and also in recent times to understanding disease and health in societies, in the form of also playing a very critical role during the pandemic. Gautam is a professor and also holds a position of Dean Research at Ashoka University. He also had a long stint as a professor at IMSC, Indian Institute of Mathematical Sciences at Chennai. Prior to that, he also has a very long trajectory at IISc, TFR, and other places. And one of the fascinating aspect of Gautam is, as I mentioned, the kind of discourse he brings into any part of the discussion what you actually have. And I'm extremely delighted to have Gautam on Pratidwari. Welcome, Gautam.
Thanks, Pawan. It's an honor to be here.
Yeah, my pleasure. So, Gautam, we are going to actually get started with the question of what really motivates you to do science. And this is a common question I generally ask people, and connect that particular aspect to your origins, and tell us how you really got interested in science.
So I'll sort of start with the first question
Yeah, yeah.
as to what, and I realize that it's been very clarifying for me now that I do administration to figure out that what I really, really like to do and what I really miss is doing full-time science. So I think that's in a sense is an affirmation of the fact that what I was really put on this world to do and what I enjoy most is science. And I miss it when I'm not doing it and I miss time away from it. So you asked about what were my origins in thinking about this.
Mm,
And I think as a young man, I grew up in the south. I grew up in the
mm,
city called Kochi by the ocean, and I was very interested in science. I think really, if you sort of looked at my reading, I was interested in medical science. I was interested in physics. I was very interested in chemistry.
mm,
And I still think that the most interesting entry point for a young person interested in science who doesn't know the difference between physics, chemistry, mathematics, biology, etc., is chemistry because it's something tactile. You
mm,
can do things. You can actually see a cause and effect relationship between the stuff that you mix up. So I thought chemistry would be my direction for a while. Then, chemistry and then medicine is also something that I was interested in
mm,
more from the point of view of the complexity of the body and what puts it together. But then around the time that I was applying to college, I was, very taken in by the beauty of physics. And I think what really made the difference for me is I felt that chemistry one had to remember many things.
mm,
Whereas in physics, you actually do the stuff that you have to remember is actually very, very little. You can remember your Maxwell's equations, your Newton's laws, your Schrodinger equation, and all of the complexity of the world you can actually recreate from just that. And that extreme economy, I think, is what really drew me into physics. I had other interests. I was interested in South Asian studies, history, etc., etc. And it was kind of a toss-up between things that I was good at and liked to do, but also physics. But I think that's where my orientation towards science and the fact that I found the simple beauty of being able to put together extremely complex things from very, very simple beginnings was actually apparent. And
wonderful,
after I
wonderful.
finished my bachelor's, I went on to my master's. And at that point, I think, like many young people, what I wanted to do was very theoretical stuff.
Mm, mm,
And I view this in a sense also as a lack of my training, both at the school and the early college
mm,
level, that you're not trained to understand the beauty of experiments. You think of, in fact, I remember as a summer school when I was younger, and as a young undergrad going there and being asked, what do you want to do? And I said that, look, I don't want to do experiments. I'm just not cut out for that. And the person who asked me this question looking at me a bit sadly and saying, the problem with all of you is that you think that experiments means practicals.
Mm, mm,
And in a sense, that was absolutely right. I realized that
yeah.
what I had thought of experiments was writing a book, objective, this thing, apparatus, and the whole stuff below, and a conclusion at the end, and a graph. That's not it at all. But it took me a time to become mature enough to realize that I was missing the whole basic point. So as I said, I wanted to be a theorist in a very technical part. I wanted to work in quantum gravity. And then I was blown away by one course that I took in the last semester at IIT Kanpur, which is taught by Jayanta Bhattacharya, who taught advanced statistical mechanics. And I just sat in this class and watched him on the board, and I said, "Wow, this is really what I want to do. There's an elegance to this that I'd been missing so far. It's not
Mm,
so technically complex that you sort of tend to write pages and pages of mathematics, but it's full of ideas and complexity and beauty just in thinking about how do large numbers of particles actually behave, and is there a simplicity that comes out of that complexity. So then I made up my mind. Statistical mechanics, condensed matter physics was really my direction. And then I went on to do a PhD in that area and
wonderful,
explored many other
wonderful.
interesting things.
I'm very sure there would have been some role within in your house, and also probably the influence of your parents in also these orientations, because I know that you also have very deep appreciation for art, music, and other things. Where does that come from, and also the connection to your own upbringing at home? If you can just make some comments on that, that will be nice.
Yeah, I was lucky because my house was full of books.
Mm,
It was also full of music. My mother is a trained music teacher. My father had a background in Hindustani music. So both Hindustani and Carnatic music were very much part of my growing up. And my father was a sort of academic, a sort of intended academic who then moved out and did other things, including start a school, especially for children
mm.
with multiple disabilities. But because of his academic background, he had this incredible library of about 5,000 books at home, and
Wow.
that covered everything, full biographies, novels, etc. Not much science, a little bit of science, but much of it was history, political science, biographies, etc. So I grew up reading. I would constantly read wherever I went, wherever I traveled. I think that's, in a sense, among the best upbringings that a young person can have, because I was not pushed to read anything, not pushed to do anything. So all of this stuff was there in the house. So I grew up on a diet of music and of reading and of meeting interesting people who came home. All of this, I think, added up. I think I was very fortunate in that.
Mm,
And I
mm.
would hope that everyone has some level of similar fortune, maybe in other ways, but just exposure to ideas at an early age that can help form you, I think is very important. And I was lucky in that.
Wonderful, wonderful. This element of getting exposed to books, it's something which is very common to a lot of people, irrespective of their kind of economic status, because India has very interesting complexity and also diversity in terms of how children grow up. For example, there are a lot of children who also get exposed to books, not at their homes, but at various different places, especially down south, because there's also some culture of storing books in places. It's not prevalent across the country. There is some kind of distribution there too. uh, this is something which I'm always intrigued by, because I know in Kerala, of course, there is a very rich culture of that kind. Even in rural Karnataka, for example, or even some places, Bangalore has a lot of public libraries. At least they had. I don't know what is
Yeah.
the situation now. That is something which is quite remarkable, because that culture of reading uh, is something magical, right? Because I'm very sure that would have influenced you a lot. Was there any kind of books which really influenced you, Gautam?
I think the one book that influenced me was a book called My Family and Other Animals by
Nice.
Gerald Durrell. I mean, it's one of these extremely popular books that really have to do with the natural world outside. And what makes a difference there is that Gerald Durrell, of course, a naturalist who went on to found a
Mm-hmm.
zoo and so on, wrote multiple books about his travel and was actually much more famous than his brother, who was the real literary figure in a sense, Lawrence Durrell. But that's beautifully written. So for a young person wanting to know about the natural world, that's a great introduction of the beauty of the natural world and complexity of the natural world. That's a great introduction. That was one book that was certainly important to my growing up, although there were many others. It's interesting that you mentioned libraries, because I think
Mm.
Karnataka especially has sort of a very good library system in rural Karnataka. I think
Yeah, yeah.
Mahadevan
Yes,
Dasgupta was the person who set up
yes,
these. And it's wonderful to watch the photographs of young people with their grandparents coming there as sort of common space within the villages, within the small towns where people can come to. And that helps really to build a sense of community. So I think that's extraordinary. And you can really see the difference between the South and the North in terms of penetration of public libraries, in terms of the numbers that we have. That I think is really, we should do much more of that.
much more.
Not
Absolutely.
just not just because it encourages people to read,
Mm.
because it encourages a sense of community and brings different age groups together and caters to many different levels. We all we all need that sense of community in a sense, even as it's being increasingly fragmented now.
So very well put. You know, you also mentioned an important point of not only just bringing people to read, but bringing people together. That is actually probably the more
Yeah,
important motivation to do this. And also, I felt that library is a place where there is not only the togetherness of all people coming there and then sitting down, but there is also an element of exploration. It's something I also felt a long time ago when I was even a postdoc at Purdue. There was a public library which was part of the West Lafayette place where I was living, and I was amazed to see the public library which was there, which was open to everybody. It's not just only the university students. And the sampling of the people you get there need not be just only the people whom you generally interact with.
yeah,
Of course, it can be even a tea stall in in any other place. I'm not telling that these are the only places, but there is something uniqueness because you're really ordering the world to come over there, and you're entering that world. It's a unique experience, and I'm very glad that you also mentioned about the Dr. Uma, who actually has done outstanding work. In fact, I would also
that's
be
right.
kind of giving it in the reference, and that aspect is very very important. Is there also something which is very specific to physics which you also got exposed to during your formative years? I know later on, of course, you developed very deep interest at Kanpur and other places, which we are going to come to. But is there any specific seed of interest in physics which you can remember, or you have any kind of
I think I
memories
had the
of?
sort of standard popular books on physics, books on Einstein,
Mhm.
relativity, etc. I had no book on condensed matter physics, and this still remains a sort of gap. There are very few popular level
Absolutely.
books on condensed matter physics, and many parts of physics that are targeted at younger people at a stage where they're thinking about what to do when they grow older. And but it's very easy to find books on relativity, particle physics, string
Yes.
theory, black holes at a popular level. This sort of captures the popular imagination. But about quantum optics, or whether it's kind of matter physics, soft matter stuff, fluids, etc., there's very little.
Very
That
little.
is a
Yeah.
gap. And so it took me a while to figure out that look, there's a huge universe out there that I had not read about when I was younger, that really deserved special attention.
Wonderful, wonderful. In fact, I agree with you on this particular point. Uh, if you look at also, there is a kind of diversity within this sub-disciplines of physics, how they interface with the society. Astrophysics, of course, people come into that. That's
That's
actually
right.
one of
Yeah.
the.
That
In
that
fact,
needs, that needs no selling at all.
no,
That needs
no
no
selling
selling
at
at
all.
all.
Yeah.
Actually.
And I'm guilty as charged because the reason I actually got into physics was because of that. And of course, this fascination and also, remarkable aspect of, trying to understand matter at extreme scales is something
Yeah.
which is of very high interest. There's also an element of, something which is kind of, easily available to your senses. May also be another reason, but biology is coming back. In fact, that is another reason I would want to pick your brain on that. I'll ask that question later. But now going forward, was there anything within your family or somewhere which influenced you to kind of make career choices, or were those choices mainly of yours? Were you given enough freedom to take that?
Those choices were really completely mine. And sort of,
Mm.
if anything, my father might have preferred that I did something a little more humanities and social sciences
Yeah.
oriented, because that was his own background. And he felt that it would be easiest for him to talk to me if I worked in those areas. But I moved very far away into physics. So he could just sort of admire the subject from a distance, but could not really connect to it in a way that someone who was into it could actually. So I had I was not restricted at all. I was able to do whatever I wanted, choose whatever direction I wanted. And that's something that was, very important to me to be able to find my own path.
Very interesting. So I would also want to know the physical trajectory what you took, because you grew up in Kochi, if I'm correct, and then you suddenly go to the northern part of the India where you now start your bachelor's at St. Stephen's. And
That's
how
right.
did that transfer happen? What was the story behind that? Mhm.
So I studied in Kochi till the 10th standard,
Mm.
and then from there went to Kodaikanal for 2 years to a boarding school.
Oh,
And
wow.
from there made the jump to Delhi, as you said, St. Stephen's College, where I did was an undergrad, did a bachelor's honors degree in physics. Again, some really outstanding teachers over there and very, very committed teachers. I think most places in India, I mean,
Mm.
provided they have been completely destroyed, have at in colleges at least one or two or three teachers who are deeply committed to what they do. I mean, this has changed with time. And it's not necessarily changed in a positive direction, but certainly at the time when I was in college, pretty much any college that you went to had at least one or two people who were really deeply invested in the subject. They may not have been researchers, but they were great teachers. And
Mm.
they would essentially let you, guide you in ways, even if they were not expert in that themselves. So I had those sorts of teachers. And then I went from there to IIT Kanpur, met a set of completely different and outstanding
Uh,
teachers. And again, very good people, in the sense that the people who guided me, in Professor H.S. Mani, Professor J.K.
mm,
Bhattacharya,
mm.
many others who were in the department at that time. Kanpur at that time was probably the best physics
Yes.
masters in the country. And of course, many people from there went off abroad and did very well. Many people within my batch and junior to me, etc. But I had an outstanding education there. I think I really
Mm.
could not have had a better training there. And from there, I went to the Indian Institute of Science to
Yeah.
do. So the story is that I actually registered at IIT Kanpur to do a PhD with J.K. Bhattacharya.
Oh, did you?
And then
Okay, okay. I didn't know.
a few weeks later, the Indian Institute of Science made me my offer. So I was thinking, look, there's this place. I've heard a little bit about it. I don't know enough about it. Maybe I should just go and ask him what he thought. So he was extremely generous. He said that, look, with the choice of here or there, I would suggest that you go there. There Professor Ramakrishnan, many
Mm.
others who are very good. And that is really the best Condensed matter group in the country. So I really think you should go. So after 3 weeks in Kanpur, I up took my bags, went off to Bangalore, joined that department. And I was in the theory group. At that point, it was streamed to either theory or experiment. So I was one of a small batch that went into theory. Again, a transformative experience to be there. It was, you sort of make these decisions at various points and you're not sure why you did this or that. Life pushes you in strange ways.
Mm.
But again, that was a wonderful place to do a PhD at that time. And I can tell you one thing about it that is very different from conventional places. It
Mm.
actually didn't matter who you were registered with. You could work with someone completely different from the person you were registered with. And I essentially worked, there were, I think, six people who were theory people in that department at that time. I worked with five of them. So
Wow.
I wrote
Okay.
papers by the end of my PhD with five different, in quite different areas. One on superconductivity,
Mm.
some on soft matter physics, lattice polymers,
Mm.
something on membrane phases, etc. So it's a combination of both thinking about what is called hard condensed matter physics as well as soft condensed matter physics. And I was exceedingly lucky to be able to do that, to be able
Mm.
to essentially sample the working styles and working philosophies of very, very different people, very, very accomplished people in different ways, as well as make a whole bunch of friends who are still with me. So that was a particularly important point in my training, in my own training. And that I don't think, again, I don't want to use too many superlatives. And I'm sure I might have said this where had I gone anywhere else,
Mm.
I'd gone to, ISER Pune didn't exist at that time, but Delhi University or something. I'm sure I would have found something good in each of that. But now looking back at how important that was to me at a transformative point in my life, I really had it very good in terms of the
Nice.
training and the people that I actually managed to meet. And they were very fine people.
Yeah. Yeah. In fact, the one of the elements of IISc physics department, and that is something which is still kind of very prevalent there, is that it actually enhances your interest in physics. that is something which is very unique to the place, because why I'm saying this is also from my personal experience, because as a student at JNCSR I took my coursework at IASC, including Balram's last course before he became the director. That
I
is
see.
another
Yes.
privileged course I really had the honor to take. But I felt that, for example, even as a student you go and attend a talk there, there is a degree of openness. I'm saying this, as you correctly mentioned, this might be there in other places too. I'm no way actually discounting that part of it. That openness, and there is some kind of a kind of welcoming nature about that environment. Including in talks, people are really not very rude, but you still actually get to learn a lot of stuff. This is the same experience I had as an undergraduate when I attended the famous Journal Club lectures at RRI, where N. Kumar was sitting at the front and leading the discussion. And we as undergrads used to just go and crash there in Journal Club meetings. And although you do not get many of the things, but you could see what is the discourse
Yeah.
kind of. That is something which is very fabulous about that community. I felt that there is a good culture of that kind. I would want to also pick your brain a little bit more on the IIT Kanpur experience, Gautam. Especially, you did mention about the JKB's kind of interaction you had with JKB, and also Professor Mani and other places, other people. Were there also any specific kind of questions which you were already thinking about, because you had interest in quantum gravity and other kind of areas? I'm interested in looking at specific questions. Were you already having some kind of a question or some broad kind of inquiries which you can carry? Sometimes you do carry, right? Because I'm very sure even now you would be actually doing that. Did you have that kind of some specific orientation then?
Not so much with the quantum
Mm,
gravity stuff that I was
mm,
interested in. It just seemed very complex. I bought all the books. I
mm,
bought Paul's
mm.
book on gravitation. I went to Delhi University when Chandrasekhar was visiting,
Oh,
listened to
is
his
it
lecture,
okay?
etc.,
Nice,
etc.
nice.
Yeah, so that was, in fact, yeah, even later, whenever Chandrasekhar would speak, I would travel all the way to wherever he was speaking to listen to him. I'm still, even as I moved away from thinking about gravitation and etc., I'm still very respectful
Right.
of this person's contributions and so
Mm,
on. I think the one thing that really struck me at Kanpur, as I said, from Jayanta Bhattacharya's
mm,
course, JKB's course, was the idea of the renormalization group.
mm,
And I was struck by the beauty of those ideas as a master's student. And in a sense, that wonder has never really left me. I still think Kenneth Wilson's contributions to building the renormalization group and to those ideas is so fundamental to a really modern way of thinking about physics. That the idea of that you have to think about physics across scale, that interacting systems can be very different from non-interacting systems, that we can actually compute things that are that critical exponents, critical amplitudes, and compare them to real life and figure out why is it that the three-dimensional Ising transition has the same exponents as the liquid gas transition. I mean, where these the beauty and complexity of these ideas and the fact that they can be turned into calculation tools was really an eye opener to me.
mhm,
So,
mhm.
if anything, there's one idea that has stayed with me from the point when I was in my early 20s doing my master's to my sort of advanced stage at the moment is the idea that the nomination group way of thinking about how physics happens across scales is one of the most beautiful ideas of modern times.
Wonderful, wonderful. This is a point I would want to also pick a little bit more, is that this is also a particular stage of a student's life. I'm just looking at your kind of point of reference there, is the importance of utilization of mathematics in physics, because if you really want to even appreciate renormalization, you need to actually have some rudimentary understanding of slightly advanced mathematics, and also that realm of taking or rather the ability to take abstract ideas and formulate into or mold it into something which leads to observables is also hallmark of these great people you just mentioned about. um, because I'm always curious, because it just a lot of theoretical physicists actually have this unique ability to really grasp mathematics in a very elegant way. experimentalists also get exposed, because all of us who do MSc physics have the same kind of training in mathematics, whereas it also becomes a little bit more geometrical, calculus based, complex analysis, because the tools of mathematics, what let's say an experimentalist uses, would be slightly different. For example, whenever I talk to my colleagues, I extensively talk in the language of Fourier series and integrals and other things, which is which is extremely useful for us as experimentalists.
Yeah.
Whereas if you now look at theoretical physics, group theory and other kind of realms are very critical. I just want to know what is the kind of exposure to mathematics you had, because that also surely plays a critical role in your future research. Yeah.
That's a great question.
Mm,
And I don't think I'm particularly mathematically gifted. I'm fairly
mm,
average as a mathematician. And so I admire people who typically, sort of people who do string theory or
yeah, yeah,
mathematical
yeah.
physics of various types, who are mathematically much more oriented.
Mm,
I prefer to argue from the physics and let the mathematics follow. And if that if I can see it in my head, what might be the likely result, I have
mm.
to have to do that argument inside my head.
Says.
And then the mathematics can come. I'm kind of
Mm,
slow and plodding in putting the mathematics together. So my own relationship with the way mathematics enters my field, I don't do very complicated stuff,
mm, mm,
but it's more what is fit for purpose. And for that, you have to really think about what techniques are appropriate. When do you do a computational lattice model? When do you do mean field theory? When can you do a little better than mean field theory? When do you have to go to a field theoretic formulation of something? So that really depends upon the subject that you want to attend. And because I have worked now in a couple of different areas, the mathematics unfortunately has been different in each of them.
each of
When
them.
you talk about the mathematics that applies to the equations for disease modeling,
Mm,
that's
mm,
typically types of time series analysis would be one thing, dynamical systems would be another, which is very different from the stuff that I started out with. I mean, much of the stuff that I did for my PhD was liquid state equations, which you have to do numerically. And then make approximations are very central to that. I think as a condensed matter physicist,
mm.
you get very used to the fact that you can't solve anything because it's all too tough. So the secret lies in the approximations that you make and how do you, and for that the physics has to enter. You have to have
Absolutely.
a very clear physical understanding of your system and exactly the crucial, clever approximation at the right time that takes something that is completely unsolvable and turns it into something that you can genuinely derive intuition from. I think that's where really, and I would not, I normally tell people, usually people who come say, look, we like physics, but we can't do mathematics, we hate
Mm,
mathematics, etc. And I see a lot of them when I teach
mm,
undergrads, especially. And my point is that, look, if you're interested enough in the problem,
mm,
the
mm.
techniques will follow. You have to be interested in really understanding, finding out the answer. And then there is no obstacle in your path after that, and you will learn what you have to learn in order to do that.
Fabulous, fabulous. It's such an important kind of message what you actually are departing now, because this putting the question in front of the method is also very critical, right? Because generally, if you have a very well defined question, as the saying goes, if you know the why, the how actually somehow manages to make its way. And this is very crucial also while students are getting exposed, especially the crucial junction, as you mentioned, is around the undergrad to masters. That's the reason why I'm actually discussing this, because a lot of people make this crucial decision at that junction, especially at the level of bachelors and masters. Because if you talk to anybody who actually has a career, furthermore, the seed of getting into the problems of interest, or rather the areas of interest, actually are kind of sown in that particular time. And this also brings me to the question of your experience as a student during your bachelor's and master's. How was it like? How are you in terms of, let's say, uh, performance and other things? Did that really play a role or anything? Mhm.
That's a good question. I don't think I was a particularly good student. I
Mm,
mean, mainly because I sort of shifted various. I went from a school, international school,
mm,
to the deep immersion in the Indian Delhi University system. And that took time for
mm,
me to adjust to. Then moved to IIT Kanpur, which is really undergrad BTech centered, and then had this
mm,
physics part to it. And I think I really began to understand many things when I joined as a PhD student.
mm, mm,
And mainly because I think, so this is something I also tell people that in order to really understand something, you probably have to listen to it multiple times. There are very few of us who can sit in a lecture and figure it out beginning to end right then. And so I think by the time came around to quantum mechanics the third time, all of the questions that I thought were dumb questions, I suddenly realized were actually very good questions. And so, which is why, again, I encourage students to ask whatever question. All of us do that. Whatever question that you want, there is no such thing as a truly. If it occurs to you, then it's a worry that is shared by other people who are sitting next to you. You should never not ask a question because you think the person next to you has probably got the answer to that and you don't want to be embarrassed about it. So I think the ability to really ask questions, to think about them and ask and understand that these are not bad questions. It's, in a sense, they clarify something that you hadn't understood earlier. Really came to me only by my master's, which I'm sort of ashamed to admit it. I should have been someone who was a prodigy and knew all this stuff long ago, but that wasn't the case. So I think learning how to learn
Mm.
really, I think, came to me at the end of my master's, early part of my PhD. And learning how to learn in a very specific sense, not in the
Mm.
sense of doing well in an exam, understanding the stuff and then forgetting it as soon as you write the exam, but to make it a part of you so that even 30, 40 years later, you can reconstruct those ideas. And because they've been imprinted in you, you've understood the core of them in a way that you would never forget them. I think that is something that came quite late. And some people, as I said, the really top people in the field would have probably been much more natural at it.
So please do share about that. How what is your learning on how to learn to learn? Please do let us know. That will be invaluable kind of lesson for all of us in here. Yeah.
I don't know if there's one
Yeah. Tell me now.
shape that fits all,
Mm, mm,
but I think I'm very interested in many things.
mm, mm,
And I think there's nothing that I could not be interested in at some
mm,
level. I can sit in a seminar on,
mm,
here I sit in lots of seminars in lots of different things, whether it's immunology, whether it's
mm,
in history or sociology and anthropology, which is a fascinating
mm,
field.
yeah.
And I'm actually interested, and I love to talk to practitioners who are good at what they do. Because in seeing what they do and how they think about their field, I get a sense for what motivates people, what ideas motivate them, what are the overarching sort of dimensions in a particular field. And I'm happy to do that. I notice that some people shrink away from, they're very
Mm.
focused on what they do. They know that they're outstanding in a particular area. I'm not like that. I wish I was. I wish I had that level of concentration to be, but I'm much more of a generalist.
Yes.
And in a sense, that may be both my strength and my weakness.
Great.
That enables me to connect different areas together. But I might have had more of an impact had I been very, very concentrated in one area, thinking about nothing else for 20 or 30 years. But
But
we are driven by our own personalities, we're
personal.
driven by our own training, we're driven by the sort of people that we are.
This is a very important kind of also, there's also related psychology, right? Because it also depends on an individual and how that person kind of, couples to his or her environment in the way one actually gets exposed to new ideas. And I've read a lot of stuff what you've written, and also, because we are friends on all the social media platforms, very one of the most I would not only call entertaining but also most educative part of being online is to
Thank
actually
you.
read what Gautam actually posts. In fact, I have to mention that, Gautam, because this is something which I genuinely feel that because that's one of the few things I really look. I'm really not much into the social media because I'm more of a poster than than actually the person who engages in anything. Because I use all these platforms to just post this stuff because most of the time actually purposefully I'm away from it.
Yeah.
And But I felt that that is something which is very very interesting, Gautam. I have felt that and I keep telling this in various different blogs and other places, is that the exposition can also have an element of exploration. And I see that in the process of actually putting it across, and that includes even social media posts for that matter, you will have to somehow articulate certain things. You'll have to first probably digest a little bit of stuff what you're really trying to communicate. And I felt that you also have the ability to pick something which actually make or focuses the point to its most essentials, and also you have a kind of a very nice discussion because a lot of people do engage. I've seen that so many of them, it's not only during the COVID times, I have to mention to our audience, but even before and also after that period, there are so many things which are in flux and in discussion. And I found that that is a very crucial element also in somebody's creative life. As you mentioned that you are interested in so many things, there is also a room for one to learn something which actually is sometimes not even in the realm of your, in your field of view, so to speak, coming from the optics kind of viewpoint. That is something which is very fascinating. And I'm also kind of amazed about the breadth of the topics which you are interested in without compromising depth. That is something that you do get a lot of people sometimes who are interested in various different things, but there's a uniqueness in that you actually are able to bring this together. There are only very few people I've seen that doing, and you're one of them. How what is the part of your own kind of knowledge kind of foundation or something like that, which has really made you go towards that kind of divergent way of looking at the world? I know it's a long-winded question, but I thought I should explicitly mention this point. Yeah.
Now, my interests on social media, I mean, what I post, what I look at, what I highlight, all reflect my own interests. So, if you
Mm.
will, if you, since you sort of looked at what I post, climate change and sustainability
Mm,
issues
mm,
are something that worry me.
mm,
And that from a public health point of view, what are going to be the long-term consequences of climate change? How will our planet deal with it? Public health in various forms, the decolonization of public health discussion, where you tend a little bit more towards larger questions
mm,
that are moral and ethical in nature, something that, as well as sort of public health practicalities. Since I'm interested in modeling, that's one other part where it comes. The nature of the creative process in whichever field it is, typically in the sciences, in physics, in biology, how do people come up with ideas? How do they put them together? That's another area that I'm very interested in, which I highlight. And the odd stuff, some really clever breakthrough in CRISPR
mm,
methods for treating diseases, or some very clever experiment on friction or something
mm,
like that.
mm,
That reflects again the sort of scientific areas that I'm thinking about. And then, of course, other sort of very burning issues of our time, for example, Israel and Palestine at
mm,
the moment, other types of things, odd notes about the American elections, which
mm.
technically we're not that interested in. That's their problem, not our problem. But also issues regarding communalism in the country, which
Mm,
again I think is very different from the way I was brought up with. I was brought up in a fiercely secular family
mm,
in where the communal integrity and the communal togetherness. I grew up in a town or city which was actually fairly well balanced between different communities, and
mm,
everyone got along. It wasn't a whisper of communal riot or communal unrest at any point. I had a full range of friends I grew up with from multiple communities, multiple parts of India. It was a little microcosm of all of India at that point. So that's again something I feel sort of that I'm very much freedom of the press,
mm,
freedom of expression, freedom of speech, freedom of scientific expression are all, I think, very core to how I think of science. And you cannot have, if you don't have freedom of expression, you don't have freedom of speech, then you cannot be do good science. You have to sort of
absolutely.
stay where the science is leading. So
Absolutely.
I don't see many people writing about this from the scientific
Mm,
angle, from people who are scientists
mm,
who make a point of this. I do because I think it's important to me. And I'm not really writing for an audience or
mm,
highlighting
mm.
things for an
Yeah.
audience. I'm doing it for myself,
Myself. Yeah. Yeah.
essentially, because this sort of defines my own thinking, where my own standpoint is. And I'm happy when people sort of read what I post or read what I highlight, or agree with some of the points I make, because I think it's also important that people know this is how scientists think, people
Scientists.
who
Yeah.
are in the
Yeah.
science. And it's not, there's this sort of thing that looks, scientists are not interested in the world
Mm,
outside. It's the humanities and social sciences people who have opinions about society, who have opinions about politics, etc., etc. And I wanted to say that that's not the case. I mean, we all live in a society. We're all responsible for what society does. And it's up to us to freely describe what we think and get into some sort of engagement, even with people who don't agree with us.
yeah.
But
Absolutely.
we must have the courage to make our points.
The last point you mentioned, even to engage with people who do not agree with you, I have seen that you doing. I mean, at least online and at various different platforms. That is something really commendable, Gautam. In fact, I should really make it a point, because in the rhetoric of kind of communicating on, or rather in the rhetoric of actually making a point, one sometimes actually does not listen to other voice. You may totally disagree with that, and the fact that you actually do engage with them is something which should strongly be encouraged across various different platforms. You might not agree. That's the point, actually, right? Because in fact, that is the place where you may have to engage more, and that
And
is
in a
something.
sense, that's the hardest of it all. I mean, to not
Exactly.
argue,
Yeah.
to not call the other guy an idiot because he
Yeah.
disagrees
Yeah.
with you. That's the
Absolutely.
hardest thing to do. So you should not take yourself so seriously. You should not take social media so seriously.
Seriously, yeah, absolutely. No, I should mention to the audience that Gautam also holds very important and key positions as commissioner on the Lancet Commission, right? On strengthening the use of
Lancet Commission.
Lancet Commission on strengthening the use of epidemiological modeling of pandemic diseases. And another very important point is that he's also a member of the WHO Technical Advisory Committee on embedding ethics in health and climate change policy. Climate change is something also I'm very, very, deeply interested. And also, I'm very fascinated by how people actually did realize that there is a problem. That is we might actually be a little cynical that not much has been done to even come to a point where there is some kind of historical evidence now to really make a strong case is already a very big thing. And I'm very interested in that kind of evolution of those ideas, all the way from some very interesting experiments on greenhouse effect, etc. So now I'll just move towards your IAC part of the work. uh, Please define to us broadly your research questions you were trying to address during your PhD time, and also the broader lesson what you took out from there.
So the main problem that I addressed in my PhD was, so this is just after I joined ISC, just after the first flush of ITC
Mhm.
in 87. And there were, everyone, every sort of condensed matter solid state physicist in the world pretty much began to work on ITC as a sort of the new frontier. And there were these fascinating results coming out on what are called flux lines in
Mm.
superconductors. So very quickly to describe this for your listeners, there are two types of superconductors. One is simple elemental superconductors, niobium, etc., which have a very simple phase diagram, that they have a phase which is superconducting, in which the field is pushed out. Any magnetic field that you apply is pushed out. So there's a normal phase where the field enters and a superconducting phase where it is pushed out, called the Meissner phase. In type 2 superconductors, on the other hand, which are by far the largest class of superconductors, there's an interesting intermediate phase, which really is much of what the phase diagram superconducting region is, in which the field enters in the form of lines of
Mm.
quantized magnetic flux. So it's these lines can be, there's several hundreds of angstroms in diameter, let's say, and you can control the spacing of these lines by tuning up the magnetic field. So you can think of these lines which interact with each other as a statistical mechanical system
Mm.
of
Mm.
interacting objects. So the questions at that time were, how does one think about the statistical mechanics of these interacting lines, and can you relate that to experimental observations? One major observation at the time was a possibility. These lines form a lattice because they interact, they form a triangular lattice at low temperatures. As you increase the temperature, the lines begin to fluctuate. And at some point, potentially, this lattice could melt into a liquid of lines, as we know of the melting transition.
Mm.
So the question would be, what is the signature of the melting transition? What are the properties of this melting transition? What is the entropy change in the melting transition? What are the experimental signatures of the melting transition? What does disorder do? If you have a disordered material, which is a superconductor, what does that do to the melting transition? And can you compute all this? So this was my interest in my PhD. First of all, the computation of the melting transition, the computation of what happens, what does disorder do to affect the transition? What
Mm.
do certain types of experiments, the muon spin rotation experiments, how can they act as probes of the transition? These are questions that we looked at. And in this involved taking techniques from statistical mechanics, from what's called liquid state theory applied to the superconductors, understanding a whole bunch of stuff about superconductors in order to be able to make this mapping from one to the other. And I learned about many new phenomena that would actually occupy me for the next 10 years after that, something called the peak effect in superconductors,
Mm.
in disordered superconductors, which was very important to my own thinking about what I would do after my PhD. So I spent many years thinking about that particular problem. But this is what we did, a whole range of problems that really had to do with the structure of lines in superconductors, thought of as a problem in statistical physics.
Mm. Wonderful, wonderful. So, which means that you actually are also kind of, looking at a quantum mechanical system from a statistical viewpoint, which is a wonderful, exposure to understand also complex systems. Was there also some kind of a seed here for your further exploration, where some of the lessons what you learned probably were utilized in the future?
That's a great question. Of course, I mean, I think the complexity of interacting systems and the difficulty of devising techniques for them is, of course, central to this question,
Central.
as it is to many questions in
Many.
statistical physics and in condensed matter physics. So that was also fairly central. But I think the most important lesson from that is looking at experimental data.
Mm.
So I worked with a group at the TIFR Bombay, a group that was completely experimental. Shobha Bhattacharya was there along with
Okay.
other people. And we wrote physical review letters when I was a postdoc, which was, I think, one of relatively small number of PRLs that were coming out here for Bombay at that time, on looking at the melting transition at low fields. And again, so that was my first experience with working with the completely experimental group as a resident theorist, looking very, very carefully at data and discussing data in detail, measurements, what is part of those measurements, and trying to relate that to theoretical framework. And that
Framework.
really helped a lot in the other work that I did. I did a lot of work with experimental groups after that. So we wrote a set of 3 papers on muon spin rotation in superconductors
Mm-hmm.
with a completely international group. In fact, I had
Group.
never met any of my collaborators. They wrote to me saying that, look, you seem to be expert in these techniques. Can you help us with this data? And we worked online for a bunch of years together. It took me some years to meet everybody. And even then, I don't think I've met everyone I've collaborated with on that. But the ability to sort of ask the right questions
Mm.
of experimentalists and their ability to trust you in turn, I think was something that was important to my later work in biophysics. That's
Yeah.
how I would put it. And that I think was the most important lesson for me from that. Not so much that sort of theoretical
Mm.
background of what I did, but the idea that physics ultimately is an experimental subject and theorists and experimentalists must collaborate together to understand what questions to ask and how they
That's
should be answered.
very nice. Very nice. So, did you have an enjoyable PhD?
Oh, wonderful PhD. I couldn't have
Nice.
had a more wonderful time. I mean, it was,
Yeah.
as I said, the Indian Institute of Science was special in many ways, very
Mm.
open. And people, exactly the point that you mentioned, people would ask questions.
Questions. Yeah.
And to an outsider, they might look at very aggressive questions, but
Mm.
they were not. People were genuinely interested in knowing what was the answer. They would ask what was on top of their mind. The other thing, okay, so again, this is something that might interest your readers from the point of view and
Mm.
teachers as well. And again, this is something that I mentioned to my colleagues that the most interesting classes were those in which my teachers would make a mistake when working out things on the board. And then you could see the sort of slight confusion, the slight sort of sense of disequilibrium when they knew there was something wrong,
Mm.
but they couldn't figure out what was wrong. So they would have to retrace their path, figure out things. And some of them, I mean, that's where I really saw the magic of a great teacher and a great thinker, would be able to reconstruct the final answer.
Final answer.
They say that, look, we know that this must have a factor of E square in it because it must not
Mm.
distinguish between sign. It must be proportional to temperature to this power. We can use dimensional analysis to figure out what that term ought to be. It should be inversely proportional to the mass. And that's just recreating from physical arguments what the final mathematical answer should be. And of course, there may be a pi squared missing, etc. That doesn't matter. You realize that that doesn't really matter. The magic is in what is
Magic.
unfolding
Okay.
and how you can reconstruct an argument. So paradoxically, I thought the best teachers were those who made mistakes
Mm.
and then went back and could correct them,
Correct.
not necessarily by correcting the mathematics,
Mhm.
but by having an intuition for the answer and being able to convey that intuition.
Very, very, very well put. Because that is how most of the thinking in research happens,
Exactly.
right? Because this is something which we always talk to students too. That in fact, accuracy is an iterative process. It is not something which you really land on in one
Exactly.
shot.
Exactly.
And in fact, if anything, you should actually be a little bit more careful when you really get a right answer right at the beginning. Very, very interesting. So this also probably takes you to other places now from Bangalore to TFR and also to, if I'm correct, Vancouver
That's
later
correct.
on.
That's
So
correct.
tell us a little bit about that stint, those two stints.
So I moved to TIFR as a postdoc, and
Mm.
at that point I mean, there was sort of reasons why I wanted to move to TIFR at that point. But I worked with Sansad Verma and Deepak Dhar, who are
Mhm.
sort of incredibly admirable physicists.
I
I
should
was
mention
then very,
recently. recently Mastan Sen gave a fabulous talk on Homi Baba in one of the
Ah,
TFR Hyderabad meetings. I just thought I'll
ah.
tell. It was outstanding, actually. Yeah. Sorry,
And you, and
sorry
you
to
have and you
interrupt.
have and you have the great fortune of having Deepak there at ISET
Yes.
Pune, which is sort of an incomparably
Yeah.
great fortune.
Yeah, he's moved to
And
ICTS now. Yeah, yeah.
that's true. Until
Yeah.
recently you had him.
Until recently, yeah.
And And so with them, I was working on what's called exact stat mech, sort of certain
Mm-hmm.
one-dimensional models that could be solvable. I had no training in that before. I never worked on those problems after, but you could sort of see what it involved, what thinking that involved, what nature of simulations, and how one could make predictions for fairly complicated things with an incredible sort of spurt of intuition
Mm-hmm.
that really Deepak and Musansar came up with.
Yeah.
And then that work is now enjoying a slight sort of resurgence now because people are figuring out that in a sense relates to models that people that went through an intense sort of examination a few years later in the context of disordered quantum systems. And this people suddenly said, hey, these ideas are actually older and they came up in a completely different context. So that I worked, as I said, in TFR, I split my time between working with
Mm.
on exact StatMech as well as with the experimental group. Then I had sort of thought by then, look, what are the where is physics going? Where should a sort of sensible scientist put their money in? What is exciting? What's going to be the next 20, 30 years in
Mm-hmm.
physics? And it was increasingly clear at that time that this is going to be the time in which it's going to be biology and applications of physics and biology that are going to take a huge lot of mind space. Already, physicists had begun moving. The best people like Hopfield, who just got the
Oh,
Nobel Prize this year, had moved in the early 70s, mid 70s into that area. And there were increasing numbers of people who were just, after 10, 20 years as successful professional physicists, had suddenly decided we're going to retool completely. And we're going to go into this new area where we don't know anything, and we hope people will be kind enough to teach us. And if we're really, really brave, we'll set up experimental groups. So there are several examples of purely theoretical people retooling and learning enough experimental methods to be able to set up experimental groups in a whole experimental setup in their
yeah.
labs because they were interested enough in those problems. So there are several easy entry points, and I chose one at that time based on my interest. One was molecular motors, which are these remarkable molecular machines. They're about a few tens of nanometers in size that can move in one direction. So the statistical mechanics of this was very interesting, and that's the point where physicists began to talk to biologists quite a bit, or at least pick up the minimum level of biology required to write a statistical physics model for these things. So that was my entry point. Began to work on membranes as well, on what are called active membranes, and then on the organization of motors and microtubules. So by then I had come back, and in my Vancouver time was spent in a group that was a biophysics group, where I worked on molecular motor transport and learned a little bit about membranes. Then I came back to India and sort of worked half on high TC related stuff and half on biophysics related stuff. I found some wonderful collaborators and students. So Sunil Kumar at IIT Madras was a collaborator for a significant amount of time. He became later IIT Palakkad director, and now is back at IIT Madras. But we worked on membranes, we worked on motor microtubule organization, we worked on DNA mechanics, we worked on a whole bunch of different problems of that, all from a statistical mechanics, computational physics sort of angle. And these were sort of well-cited papers. People sort of, I mean, the DNA paper I think was particularly exciting because that was we moved very fast on that. I think the whole paper was done and completed in about 4 months, sent to PRL, and we sort of sailed through physical review letters at that time. That was a very exciting thing, along with the other stuff that we were also doing. But in parallel, I was also doing muon spin rotation, peak effects, surface melting, a bunch of questions in that. So I think both fed off each other. I was able to keep both of them in mind. The superconductivity stuff I was doing completely on my own
Nice. Okay.
so that was still keeping my hand into in calculations. Whereas the other stuff involved students and postdocs who were working with me. But that's also the time when I began to think seriously about theoretical physics and society in a sense. I mean, I thought, look, this is all very well, and I'm writing papers that are getting into physical review letters and so on, and I'm enjoying myself and I'm doing what I was trained to do. But perhaps there is ways in which theoretical physics can be more useful to
Just.
society. And that's the point where I began to think about disease modeling as something that was needed in the country. I found very few people who were thinking about this at that time. But with colleagues at the Institute of Mathematical Sciences, Shatabha Sinha in particular, we said, okay, let's just organize a meeting on that puts the disease modeling community. This was in 2005. and
Mm-hmm.
brings in clinicians, brings in public health people, brings in modelers. So let's just get started talking about setting up a modeling initiative within the country, getting people to talk to each other, finding out where data sources were. So I think we did it at this meeting in 2005, 2010, 2016. And the 16 one had become quite big by then. We had people from the Imperial College and the London School of Hygiene and Tropical Medicine come in, etc. And then that will also mark my own shift to thinking
To
about problems of disease in there and using my own training in statistical physics and complex systems to think about those problems. So that's my third transition. You can sort of
wonderful.
see how it all organically grew out
Organic.
of everything else.
But there's a nice gradient too. It's not a sudden jump, so to speak. So there is actually gradual, and that's probably one of the lessons, right, Gautam? Because if somebody is really wanting to make a transition, which is actually worth it, because you would also kind of expand as you grow older, and that particular aspect of going in gradients rather than really taking a sharp delta kind of a jump, is something which is worth doing. I
So let me let
also,
me let me just point
yeah,
out one thing there.
yeah.
And what was really important about that? What was
Mm-hmm.
important was I had a very supportive institution behind me.
Ah, okay.
I
Yeah.
did not have to worry about tenure. The institution
Mm,
didn't care what I was working. I didn't have to spend 20% of my time thinking about this or that. It was
mm.
just, your job is to do blue skies research. Your job is to train PhD students and postdocs, and to teach them whatever they need to become sort of faculty members and thinkers in their own right. And so that was very liberating. If I was tied, and being a theorist, I didn't have to worry about raising money. Thus, I applied for some small
Yeah,
grants here and there to sort of minimal just keep my hand in. But these are, I mean, we tend to underrate the importance of supportive institutions,
absolutely
but
right.
they're absolutely core to what we do. And to be able to think freely, you need institutions that say that, look, you have the time. Just assure us that something good will come at the end of it, and we trust you enough to leave you alone. And so
Yeah.
all of these, I mean, which place, where in the US would I have been able to make these multiple
Yeah.
transitions? I would have been worried about tenure, I would have been constrained to stick within a field because I would be known in that field. People would recognize me when I wrote
Yeah.
papers in that field. And therefore the paper would go to people who already knew me from my previous work. Here I didn't have to worry about that. I could actually make a transition from superconductivity where I was known into biophysics where I was not known, into infectious diseases where even I was even much less known. The community was much wider, much broader, and much more diverse. But
You
so I
know
said,
what?
this was again a special fortune.
Special, but this is something I've observed, Gautam. In fact, three people who have made this transition very effectively, and all who started as kind of slightly more hardcore condensed matter physicist. Of course, you, Madan Rao, and Sunil Kumar. All three of you have really, contributed a lot to all these realms, right from the condensed matter, slightly more hard condensed matter viewpoint. In Sunil's case, even optics, because he worked
That's
with
correct.
Rangnath, and of course, Madan also have worked on very interesting problems while working on this, and that's something also tells us about the condensed matter community, right? Because it is open to people's interests, and it gives you enough room to really go and explore. I also know a few people from high energy who also have moved to other areas, and this is an kind of underestimated aspect, and also probably something which doesn't get much attention, is that one of the advantages of working in India, if you are reasonably okay, you have a lot of scope to really explore other things. This is also my own personal experience, including the podcast, to be very frank, because
Correct.
I've got tremendous support from the community, so to speak. And that is something which is very, very fascinating. I felt that that is a unique process and unique kind of culture within the at least in physics. I've found this to be very prevalent among physicists, because they are still open enough to really welcome people who would want to actually do something. And of course, biologists have also been very, very open. I should mention that whatever interaction I've had over the years, probably you have even better kind of notion of that, which brings me to a very, very fascinating article which Gautam and Sandhya P. Kaushika wrote. And the title of that article is Interdisciplinarity, How to Make It Work for You. And I'll read the first four lines of that fantastic article. Before a priest, I am a physician. Before a physician, a reverend priest. When neither is present, I am both. When both are present, I am neither. This is fabulously put kind of, viewpoint. I really appreciate Sandhya has been on the show in the past, and it was one of the delightful, conversations I've ever had. Uh, this is something which you also are laying kind of foundation in 2018, because you are probably also, having a stack of experience on which you wrote this particular article, and also you fostered this kind of collaboration. Tell us a little bit about that, Gautam, because here you are a theoretical physicist closely interacting with people who do hardcore molecular biology. Right, also in some sense they are probably also are interested in slightly broader questions in biology. How was that experience, and tell us a little bit about that.
It's very nice that you found that article. We
Yeah.
had fun writing it, and what we wanted to do was to, in a sense, put our own experience in perspective. We worked together for many years, continue to work together too. So I think one point in there is find the right collaborator.
Yes,
If you look at
yes.
those, and I think that is very crucial. Whenever you want to enter a new field, I mean, it's the Dijen,
Vijay,
the Nobel
yes.
Prize winning soft matter physicist, has also said it's like entering a new country, where you don't know the language, and you have to rely on the kindness of people to guide you and say that, look, this is what we think. This is here's a hotel, here's a town square. This is, let me orient you, let me tell you about it, let me interpret what people are saying for you. That interpretation is very crucial.
Mhm.
Otherwise, I mean, at physicists, we tend to be somewhat overconfident, not somewhat, very overconfident about our own abilities. And we fail to realize the intellectual depth of many fields that we would like to enter. So, very important to have someone to explain. And Sandhya was the person for me who really allowed for my entry into thinking about serious problems in biology from a theoretical point of view. So we met by accident in a meeting in IIT Kanpur, probably 2009 or
Mhm.
2008 or something like that, where she was talking about molecular motors, and I was probably talking about some old work on motors and summarizing that. And she said, "Hey, I work. I'm an experimentalist at TFR, at NC base at that time, and this is what I
Mhm.
do." And that was the foundation of something that was really long term. And we did what I can always advise many people: we organized a meeting together.
Nice.
So at
That
that
is
point, we
exciting.
had some money from the Institute of Mathematical Sciences to organize a meeting. So we organized one in Pondicherry, where we brought together some really outstanding experimental biologists from all over the
Mhm.
world to that particular meeting on molecular motors and transport. So it was an opportunity for me to see the depth within the Indian
Mhm.
community as well as outstanding people from outside. So then we began to work together. We didn't publish very much, I think totally
Mhm.
about two, three papers together. But there's a lot of my own intellectual growth
Growth. Mhm.
which originates in the discussions with her to see how really good biologists break down problems. And this again may be interesting to you,
Mhm.
to you and your audience, that biologists tend to be very clever at generating hypotheses.
Yes.
They're much, much better than physicists. They
Mhm.
give them an observation, they'll give you 20, 30
Mhm.
different ways of understanding or theorizing about
Mhm.
it. And of course, the challenge there is to see which one is correct and which one is not. And for that, you
Mhm.
have to draw in multiple lines of evidence. You have to do your own experiments, which can be very time consuming.
Yeah. Yeah.
And so our interest was whether thinking about this theoretically through simulation
Mhm.
might help short circuit some of those things to find what is possible and what is not possible. And this I still hold to be one of the most important tasks of theoretical thinking about biological problems. That it sets limits. What can happen, what can't happen. If this happens, then what else can we see as a corollary to that? And we had sort of nice idea. I think one very important idea that we came up with something called the reservoir hypothesis,
Mhm.
which really has to do with how do you transport things over very long, what are called axons, the long
Mhm.
processes inside nerve cells. And how do you understand the role of traffic jams as you move stuff both back and forth in very narrow regions? That sounds like a problem in traffic
Mhm.
management. It sounds like a problem that might not, that physics enters in some sort of way that's not very specifically defined. But what does it mean for biology? So that's one of the questions that we looked at. And with Krishanu Ray, we looked at some other questions
Mhm.
about slow axonal transport. And this is the problem that I was interested in. But then, of course, I got into the problem that most interested me and which still rivets me today, which is how does the cell nucleus organize itself?
Nice.
And
Nice.
for that, I spent a year and a half in Singapore at the NUS
Anyways, okay. Yeah.
working, and where I first was exposed to these problems and thinking about those sorts of questions in that context. And that's something that led to a bunch of papers after that. And if there's any sort of serious biophysical contribution I made, is probably in that
Yeah.
area.
Yeah, the problem related to chromatin and epigenetics, which has kind of very strong correlation to that. Uh, I also know. And this is something again which is not appreciated much, is one of the formative papers on active matter was written by Gautam. There's a very beautiful review article. Again, I'm going to link that in the references. And that is actually written at a time where things were still in the formative kind of stage. Of course, probably maybe Sriram was one of the few people who had already been thinking about these questions. And I see that you also have a slightly different viewpoint, because in that paper, I would strongly suggest anybody to have a look at it. It has a strong element of experimental aspect also discussed. That is something very fascinating. I also keep reading that paper, and I also give it to some of my students to also have a look at it. uh, was that also kind of connected to these questions what you were asking, Gautam? Because these were all very this now it's actually one of the happening areas in physics, not just biophysics, in physics, the period, that's it. And these were all kind of early papers what you find. Would you want to just comment on that part, please?
So that derived from the work, the two pieces of work that we did, one on
Hmm.
active membranes and their
Hmm.
fluctuations,
Hmm.
and the second was this question of motors and microtubules, how do they interact to form patterns? And these are very, very specifically questions that have to do with active matter, matter that's in a
Hmm.
sense driven into out of
Auto
equilibrium
equilibrium.
through some internal process.
Hmm.
And so we organized, actually, we organized in 2006, I think, in ICTP, probably the first conference that looked at such non-equilibrium processes. We still rue the day that we didn't use the word active matter in the title, because that would have really been the sort of point where the
Correct.
term was introduced into the
It
field, which
is.
sort of probably happened a little after that. But that was a meeting where pretty much everyone working in what we now know as active matter at that time was
Hmm.
brought in. So the Nobel Prize winner Dijen was there. It's the first time we met
Wow.
him.
Okay. Okay. Hmm.
Many other people who are sort of stalwarts in the
Hmm.
field now. So this was Madan Rao, Sriram Ramaswamy,
Hmm.
myself, and Jacques Pro, who was at
Jack
that
Pro.
time
Okay. Okay. Hmm.
at the Institut Curie
Hmm. Hmm.
together. So we put this meeting together, and then there was this explosion of effort that happened after that. But that was, in a sense, a very important point. So the review article that I wrote was just summarizing stuff at that time. Of
Right.
course, things have moved much faster then, but that was also thinking about it at that time was also my own motivation for thinking about active matter. Chromatin is an active
Chromatin
system.
system. Yes.
And as I
Yes.
said, that's where I think, I mean, that particular work is in a sense, in my opinion, it's among the best advertisements for where active matter enters into biology.
Hmm.
And the fact that you can discuss way chromosomes are distributed inside the nucleus, their positioning, various other aspects of X and the Y, the two X chromosomes in female cells. There's all of that complexity you can generate from a theory of active matter and how this comes out. So I think that, in my opinion, there are a couple of there is some artificial system that people
Hmm. Hmm.
can construct. There are some other, Madan Rao and Jitu Mayor have done a beautiful work on
Hmm.
looking at actin and membranes. But I think this is again a sort of set of ideas that have great depth in them in terms of actually being able to calculate. I think I've said this before. The job of the theorist in the condensed matter system is to calculate, is to produce numbers that relate to experimental numbers.
Experiment.
It's not making beautiful models.
Hmm.
That
Hmm.
that is a different class of people.
Hmm. Hmm.
But if you're trained as a condensed matter physicist, your job is to
I
understand the
understand.
world quantitatively.
Hmm. Hmm. Very nice. Very nice. That's a very important message to a lot of people who would want to also get into this. So we'll also discuss a little bit of your another transition from IMSC to Ashoka, which also is a transition which actually gives you probably a new dimension, and of course new geography it also. Tell us a little bit about your own experience of this transition, because this is actually not a easy transition to make, one. And second is there is not much of data points on people who have really made this transition. Post retirement I can understand, but at a stage where you actually are kind of into your research kind of career, you make this transition. What has been your intellectual experience of this kind of transition, Gautam? And tell us a little bit about your learnings, and also broad kind of views what you have in having worked with the organization which is mainly associated with the government, and now Ashoka is a private university which actually is doing very well. and not only in humanities but also in sciences, because that is something which people don't tend to really give a little more emphasis on, because of course there are very good people in humanities too, but sciences is where you actually can see people like you who are doing very good work. Tell us a little bit about that part of it, please.
Oh, that's a nice question.
Hmm.
And I think at the point where I moved, I had spent 20 years in a fairly well-funded
Mm.
autonomous institute under government, where, as I
Yeah.
said, I had absolutely nothing to complain about.
Mm.
I was supported at all the right times. I had the money to do what I want. I organized many meetings. I did a whole lot of outreach. And all of this was possible because I was at the Institute of Mathematical Sciences, which was then and still is now a wonderful place to actually work in. But I realized some things about myself. One is that I enjoyed teaching. And I
Mm.
would pretty much throughout my career, I've taught in
Mm.
multiple summer schools, in
Mm.
classes. I've always taught
Yeah.
in usually it was at usually the PhD level, which is
Mm.
somewhat higher level, but I enjoyed teaching at all levels. So the question of moving to a place where I would consciously do more teaching, especially at an undergraduate level where you could really make a difference, was on my mind.
Mm.
And the second thing, of course, was as I was thinking more and more about public health and modeling in
Mm.
public health, I wanted to move to a place where people were thinking about policy.
Mm.
And
Mm.
in a sense, moving to an institution that was already well entrenched in multiple humanities and social sciences departments, where thinking about policy, it was explicitly part of what many people did, I thought would be new. And in a sense, I was well poised to take that step. So I reached Delhi. I joined Ashoka University 6 months, 7 months before the pandemic, which again turned out to be perfect timing because I was thinking, I came to think about infectious diseases and good policy applied to infectious diseases. And 7 months later, the sort of the true pandemic, the pandemic in living memory
Mm.
that the world has undergone, has actually happened.
Mm.
And so I was in the right place at the right time, I guess, to sort of think about these problems. And so
Wonderful,
I
wonderful.
found myself having much more of a sort of public face than I'd ever imagined. I
Mm.
found myself actually putting my money where my mouth is in terms of
Yes.
modeling, saying that look, we need to model for the following reasons to figure out what happened. What is how you should not overstate the results of modeling,
Mm.
how modeling has to be informed by data, how modeling has to cope with the continuously changing landscape. And again, freedom of the press, freedom of speech, the ability to talk about it, the need for access to information and data. All of these were questions that I actually had to confront on a practical day-to-day basis, which is why I began to write much more to try and form this interface between the technical stuff I was doing, government policy, and what the public had a right to know.
Wonderful, wonderful. Uh, it's also not a very easy transition for a physicist. Leave aside the fact that you actually were a theoretical physicist to start with. It also means that you have to have some kind of inclination to interface with people, right? Because generally, one of the motivations of doing theoretical, or rather the pleasure of doing theoretical physics, as people have been actually writing, that you can have your feet on your desk, and
And you don't
people
need
may
to talk
think
to anybody.
you don't need to talk to anybody. You can actually sit. But here is an excellent example where you actually have made this transition. I also know that you have taken active interest in outreach, not only just to students, but also with journalists, including science communication. And I've seen many of the workshops which you have been part of or even organized. And in Chennai too, you actually had a lot of initiatives of that kind. uh, how has your experience been, Gautam? Because one of my own kind of issues is that at least growing up in, let's say, 80s, 90s, science was always kind of confused with technology in the media. And even now, sometimes if you look up very big, newspaper kind of articles, there is some change which is happening. Yet there is still a room for us to really give emphasis of trying to understand what scientists do and what is the kind of questions they ask. Of course, technology is very easy to interface because there is a public aspect of that particular thing. What has been your experience? Because you do engage with a lot of media. From a scientist viewpoint, what is your take on this? Do you see that things are changing, and are there any steps you think people should take, both in terms of institutions and also in the media?
I think things have certainly changed in the last
Mm.
15 to 20 years, and
Mm.
there are really outstanding people who do science journalism now.
Yeah, yeah.
They all sometimes concentrate on specific niches. Someone may be
Niches.
interested in women and science questions, somebody more on ecology and environment. But I think overall the situation now is better than it's ever been earlier in terms of print journalism,
Mm.
certainly.
Yeah, sure,
In
sure.
terms of TV journalism, it's sort of mixed. They tend to be
Mixed,
very,
yeah.
very political. There's the quality of stuff that is pure science. Also, it's a constraint of that particular
Mm,
medium
mm, mm,
in a sense, and the need to capture eyeballs.
mm,
Um, I was very struck by the quality of health journalism
mm,
during my pandemic experience, and the people I spoke to and began to interact with were really outstanding. They really wanted to know the question. They were prepared to
question.
ask the hard questions. They were prepared to, think seriously about those answers, and they never misquoted me
Mm.
at all, which I think was really. I mean, that was a very positive
Positive.
experience. And usually, I think health is not a popular beat in that sense. So it didn't used to be a
Ah,
popular beat. Everyone, politics is where all of the excitement is and so on. So
yes.
people who do health are already predisposed in a certain way to be very serious about what it is they do because they chose it in a conscious way. So I think in journalism broadly is under multiple pressures.
Mm,
It's under pressures from the fact that the old financial models for newspapers and magazines, etc., has collapsed, and one has to derive new ways of doing it. People have Substacks, people have other
mm.
ways, and
Yeah,
the life of a freelancer is a difficult life.
life. Yeah, you're right. You're right.
So I, so my feeling is that as institutions like yours, mine, etc.,
Mm,
we should do more
more.
in investing in communication, giving some level of permanence to people who write about science, because communications and science, social science in general, academic communication is something that is going to be important in the
Mm.
future, is going to be important for us in terms of conveying what we do to the public, conveying what we do to funders, conveying what we
Wonders.
do to government is going to be important. We cannot do it on our own. You do need specialist training. You do need people who can make that, who can act as that intermediate between the scientists and between the person who wants to hear what they're doing. But I think there's a real hunger out there. And in a
Absolutely.
sense, your podcast fulfills, satisfies some part of that hunger by addressing that. People who want to be talked seriously to, who have the time to listen, who want to know what is happening in India. I mean,
India.
it's no use taking Scientific American or
Yeah.
beautiful articles in Quanta or something, because they're all focused very, very much on the US, maybe a little bit of Europe, etc. But you don't hear anything about what is happening in India. Sometimes what you hear is a somewhat distorted version
Mm.
of what should be there because it's sort of crunched into a few inches of newspaper space. So really thoughtful science communication about science in India, I think is going to be very, very important.
So, such an important point what you're making, because I also see a lot of young people, freelance actually. So many of them really doing such outstanding work, because they also come with the new methods of communication. Because that's the beauty about communication tools. Even within the realm of, let's say, the written communication, which I'm mostly the one which I tend to follow. I see that there are very innovative methods in which this is happening. In fact, it's also very interesting that a lot of things are also happening in humanities. I'm sure you know it better because you probably interact more. But having interacted also with few people here and other places, and Pune also has this broad kind of base for such kind of things. There is, as you correctly mentioned, there's surely a hunger even among the public to really get more in-depth knowledge of certain things which are really coming out of labs, and also discussions and meetings, etc. So finally, I would want to ask, Gautam, you're kind of slightly broad learning of this experience. I know you all, this is the penultimate question, because I would also want to ask about your plans and other things. But I would want to know, just because it's a beautiful experience, but also it's not an easy thing, because only a person with that inclination, creativity, and also the tenacity, only then you would be able to take such a broad perspective of science. It's actually very uh, it is an eye opener, so to speak, because you would probably get a perspective from various different viewpoints. But what has been your broad experience? What is the kind of learning you have taken from this until this particular part of your intellectual journey?
I think you should be wary of extrapolating across different people. My experience has been very unique to myself.
Mm, mm,
I
mm,
mean, I was very lucky, I think, overall. My sort of upbringing, in which I could do
mm,
pretty much, was allowed to do pretty much what I wanted, follow my own interests. The fact of having very good teachers, both at the undergraduate and the master's level, and sort of entering the Institute of Science at a time when it was really an extremely exciting place to be, when science, the sort of science that I was doing at that time, was really exploding. And having the confidence, I think the important thing about the Indian Institute of Science experience,
mm.
if I was to distill that, is the feeling that the science that you are doing is equal to the best in the world.
Nice, nice.
So I think in many ways that was important. So for example, when I can tell you what, when I think there was some point where we were trying to understand some data that was coming out of some Japanese lab.
Mm,
And I think I was sitting with Professor T.V. Ramakrishnan about that. And he said, "Look, why don't you just write to them and find out what they to be doing?" And it had never occurred to me that you could actually write to
right.
somebody far away, that they might take you seriously enough to reply to you and explain to you what you were doing. We now take it a little more. I mean, now
Yeah,
you
yeah.
have to go back 20 years to that time and to sort of my own upbringing from IIT campus, etc., to understand that, look, you're a serious participant in international science
Mm,
and people take you seriously, and there's a certain responsibility that comes with that. For me, it's these small little experiences that are, in a
experience.
sense, eye-opening and sort of suddenly clarify for you what exactly it is that you're supposed to be doing. I was supported very well by my earlier institution, Institute of
Mm,
Mathematical
mm,
Sciences, and wonderful people that I collaborated with, learned from, etc. And I've been very lucky.
mm,
Not
mm,
everyone will have the same sort of luck. And I think I've to be the flexibility and the freedom to change fields based on my own interest, based on how they change with time, my own interest in science communication, what we managed to do. I think that very much reflects me as a person. So
person.
my thing will not translate across. Other people will be very much more focused on what they do. And if you're a lab scientist, of course, there's no alternative. You can't think about 50 different things.
Yeah,
The pressures of running a lab in a particular area are very considerable and very time
definitely.
consuming. So
Yeah.
again, it's what I am as a theorist with a
Mm,
certain broad level of training, a certain interest in problems that made me what I am. So again, I would not generalize my own
mm,
experience,
mm,
but I would point to the importance of being flexible in your interests and in general of being interested in things.
mm,
I mean, it should not be cool to saying, look, I'm only interested in this, I'm not interested in anything else.
mm,
We are scientists. I mean, finally, we are academic scientists. We are trained to do things. We are citizens of the world.
mm.
We're citizens of our country. We cannot say, I'm not interested in politics. I'm not interested in voting. I'm not interested in social phenomena. I'm not interested in caste. I'm not interested in biology. I'm not interested in medicine, even though the drugs, I'm not interested in whether the drugs that are being injected to me are substandard or not.
Mm.
We have to be interested.
Absolutely. Citizen of the world. That really underlines the point because a scientist is a citizen of the world. This is actually a simple statement, but there is something profoundly important message there, right? Because our whole discourse and the lineage of ideas actually does not discriminate across borders. In fact, we owe a lot of things to all this compiled knowledge across the history, and we never actually ask. In fact, we celebrate that part of the diversity. We tell that, okay, he was there somewhere. And it beautifully still applies to whatever you do, either you're in Pashan or in Sonipet or somewhere. And that's something which I also, really admire about science. In fact, that's probably the reason why also it attracts people to do science, right? Because there is some kind of human universality about this kind of endeavor, which is very, very satisfying.
Yeah.
So, Gautam, last question is tell us a little bit about what are your future plans? What are the kind of projects you're currently and also working or kind of planning to take up and things like that?
Certainly thinking about disease modeling
Mm, mm,
and the interface with policy from a broader angle. I mean,
mm,
so far I've been working mainly on infectious diseases of a certain type, but there are many broader types that are also issues in the country, different types of disease we should be interested in. With the interaction of climate change, pollution with disease. I mean, already by staying in the north of India, this part
mm,
of the north of India, I'm cutting off effectively 10 years of
mm,
my life due to air pollution. Whereas as the temperature changes, as the world warms, there are more extreme events. all of this will affect health in interesting ways that we still don't really understand. So the intersection of disease, climate change, pollution, broadly speaking, is a very, very complex problem. And my hope is to be able to tie these different things together, these different parts together to understand how to best, how one should proceed from a policy point of view. We work in a set of models. It's called a program called Bharat Sim, which is, in a sense, the most detailed and most granular type of model that you can derive for infectious diseases. And it's very adapted to India. It's intended for the Indian population. So I want to push that as far as it goes. Also to try and understand what are called the social determinants of disease. How do caste structures, interactions, financial abilities, background affect your susceptibility to disease? For example, if you cannot access treatment, what happens to you? Because how do diseases spread within certain subcommunities as opposed to others? What do genetic predispositions do? Can we understand enough about the population to be able to make more micro level statements? Understanding how AI and machine learning can be used to put in this information, I think, is another area that's important. So that's the public health part. Biophysics, I think there's much more to do on the chromatin side, especially to understand how interactions with the nuclear envelope function. I hope I'll have the time to do that. This is sort of, time is always an issue at this sort of stage. There's some beautiful problems in superconductivity that I've been working on for the last 30 years,
Wow,
but
nice.
never still have not cracked.
Correct.
One is a problem called the peak effect in superconductors, which
Mm.
I first came across in 1995. And a couple of years ago, I thought, I've been thinking, so this has been a conversation in the back of my head, I think, for a very long time. But I need a year or two of thinking only about
Only
that.
about that.
If I have those year or two off, I would be very grateful at this stage of life. But I think that's something that has stuck with me for long enough. I think it's an important enough problem that I would like to sort of end my scientific innings with that. But whether, as I said, the question is, will time allow me to do that? Will my other commitments allow me to do that?
Definitely, definitely. I am hoping and also, anticipating that this plethora of, beautiful and interesting questions, what you've just defined, would actually not only materialize, but also throw new light onto the people who are not only just interested in this, but also it can, spark interest in people who have not been already kind of, exposed to this part of it. So, Gautam, as a researcher, teacher, as a public intellect, and as a scientist, there is so many things to learn from you. In fact, as we already actually witnessed in this particular conversation, that there are so many interesting aspects of your own life. So I'm very sure that we will also have you many more times on Pratidwani, because this is not something one-off kind of a discussion. My plan is actually to just continue this discussion with all people who are interested in science, and the basic kind of motivation is to humanize it, because that is something which is the main motivation behind all the things what we generally tend to do. So I thank you very much for your time and thoughts. It's been an absolute pleasure for me.
Thank you, Pawan. It's been a pleasure to me. I think Pratidwani is a particularly important effort at this time. All good luck for it. And I'm really looking forward to the whole series of Pratidwani as it unfolds. Good luck.
Thank you, thank you, thank you very much. So this is Pratidwani, where we try to humanize science. This time with the one and the only Gautam Menon. Thank you, Gautam.